Yeah.
Okay. My name is Larry Friesen. I'm the person who proposed this particular session on architecture for the Earth, space transportation between the Earth and the Moon. My background is I used to work in the space program at Johnson Space Center for Lockheed Martin before I got laid off. I won't give a full background in my career. You don't need that right now. But I've been thinking about these issues for quite some time. And as you will see and hear, my notions of what an Earth to the Moon space transportation system ought to look like are quite different from what was being developed for the Constellation program. I'm not the only person who has good ideas, though, so other people's comments and questions and ideas are certainly welcome here. But this diagram I will refer to, I've got just a sketch of the Earth's surface, low Earth orbit, the Moon, and then some stations that might be near the Moon in low Lunar Orbit or at the LO1 Lagrange point, and some possible paths in between these. Now, my notion is that what we need for a Earth-to-Moon transportation system is sustainability, which implies keeping the costs low. Why do I at least want sustainability? Because I want to be able to support long-term human settlement. I don't just want to go there and be able to do another Apollo or even just a lunar base where you do nothing but... I'm all in favor of lunar science and lunar research. I'm very much interested in planetary science myself, but that's not the end of it. I also want to be able to use the Moon for industrial purposes. The Moon is used the Moon's resources, and to establish a human community on the Moon. As Paul Spudis said in one presentation that I heard, the Moon is the place we are going to learn how to live on another planet. Well, okay, how do we achieve sustainability? As I've thought of it, some of the elements I think we need in a system architecture are first, fully reusable vehicles. Second, we need propellant depots and transportation nodes in low Earth orbit and near the Moon, either at L1 or in low lunar orbit. And we need to use lunar propellants. We know we can get oxygen and aluminum from the Moon, possibly magnesium, depending on how that plays into the development of rocketry to use it. Aluminum oxygen rockets have actually been tested out on a small scale, so I know that'll work. And divide the transportation system. Don't use one vehicle system to do the whole job, which is what we had to do in Apollo because we had no infrastructure there. But Robert Heinlein, back in the 50s, had a pretty good idea on how you do it. And his ideas were pretty... they stand the test of time. Basically, the logic still works. For a good reference, you might refer to his short story, Space Jockey, where you see the elements of... In fact, he even calls his Earth to the Earth surface to low Earth orbit transportation system a shuttle. And how do we divide and conquer? What are the three kinds of vehicles we use? And I'm going to go refer back to my diagram chart. We use one vehicle class will just go to Earth surface to Leo and back, and that's all it'll do. So basically, we'll have some system that will go from the Earth's surface, transport people and cargo to probably a space station or a propellant depot in low Earth orbit and back again. And it'll transport people and, if there is any cargo from the Moon, cargo back down to the Earth's surface. Never go beyond LEO. That's all it'll do. You want a fully reusable vehicle, and I can see offhand 3 possible approaches. Either a single stage to orbit vehicle, or a single stage with drop tanks, which is a concept I owe to a paper I saw in a publication several years back by the World Space Society, or two-stage, both stages fully reusable. So people who have been around the business a while may recall that the original plans for a space shuttle called for 2 fully reusable winged flyback stages. A first stage which would even use jet engines for part of its propulsion, and then a second stage to get all the rest of the way to orbit. And both stages would be fully reusable flyback systems. The second vehicle class is a low Earth orbit to the near Moon system, whether it's going to wherever you have your lunar orbit base, whether it's in low lunar orbit or in the Lagrange point. It would go between, basically all it would do is shuttle back and forth between those 2 orbits. It would never land on either body. If you read the story Space Jockey, the 2 shuttle ships of this class that he has are named the Philip Nolan and the Flying Dutchman. And if you know the background of those stories, you know that Philip Nolan was the man without a country, and the Flying Dutchman was doomed always to try around Cape Horn and never succeed. In both cases, they never land. And then you would have a lunar lander, which would look a lot like Apollo-type lunar landers, or the lunar landers that have been proposed for the Constellation system, but it would be fully reusable, so you could use the same one over and over and over again, so you don't have to keep shipping new lunar landers to the moon, and it would use only moon-derived propellants. So you would basically design the system to use a lunar oxygen, lunar aluminum, or some combination of aluminum and magnesium, a rocket system, and that would and basically refuel on the moon, and so on.
And if you pardon me for just a second,
certainly,
we have a question online in regards
yes,
to, and you can relay, an answer at any point when it's,
okay,
organic to your presentation. But we have a question online about helium-3 and viability.
Okay. Well, that right now I'm not dealing at all with the question of what resources we'll find on the moon. I have my own ideas about that. Helium-3 will not be useful with the present level of technology as a propellant system to get on and off the moon.
I'd like to interject something on that, and that's
Speak up, if you would.
yeah.
Sorry.
Yeah, I'm Jeff Larson, and I'm also a former aerospace worker out at JSC. My expertise is in operations. Many years ago, I worked on a study for a transportation system to a moon base for a gentleman who had dreams of doing this as a private venture. And among the many trade studies I did for him, I found it made had a pretty profound effect on the architecture of the system you ended up with, based on the ratio of mass going from the Earth to the moon versus the mass coming from the moon to the Earth. So helium-3, if you're looking at a system that carries basically the minimum up and tons of helium-3 back, that's going to evolve one way. If you've got another system where you're constantly taking people and material up to build your presence on the moon, and you're just taking enough helium-3 back to pay for your trip back, that would lead to a different sort of architecture and a different sort of system.
Yeah. Now, I'm right now looking at basics of what we can do without having helium-3, and with just looking at what we can do with the transportation system to make things more sustainable. In fact, this is the way I think that Constellation should have gone in the first place, even though they chose to do something different because they wanted to do it faster. Doing it the way they did it would be faster, but it would not be as sustainable. So I'm thinking that here's where you need some trade studies as to whether your single stage or your single stage with drop tanks or your two-stage with the present level of technology that we have would end up being most economical and give you the lowest operating costs for the amount of mass that you get up to orbit. Your propellant depots in low Earth orbit, you would not want your propellant depot space station transfer node to be in a polar orbit or a high inclination orbit like the present space station. You'd want a space station in about a 28.5 degree orbit, because that turns out to be probably about as good as as near optimum as you can get for going to the moon and back. There are other orbits near that inclination that would also work, but that's much better than a polar orbit or a high inclination Earth orbit.
I'd like to interject that 28.5 is the latitude of Kennedy Space Center, and that's why the U.S. uses that.
Yeah, but it also turns out that if you look at the moon's orbit, okay, and the way its orbit plane precesses and the way versus the Earth's orbit plane, the Earth's equatorial plane, it turns out that 28.5 degrees is the maximum inclination the moon ever has relative to the Earth.
And that's because the moon's orbit is inclined about 5.5.
5.5 degrees. So
and
5.5 plus 23.5 degrees that's the most it ever has. So that gives you the best chance of an actual in-plane transfer. And those who do orbital dynamics, which I used to do for a living, you know that you like your transfers to be as close to in-plane as you can get them. Every time you try to do a plane change, it gets expensive. Near the moon, you would, there are two possibilities of putting a propellant depot. Either you could have it in low lunar orbit, probably a polar orbit, which would then be able to, over a month's time, pass over every point on the moon. Or you could have a base at the L1 Lagrange point in between the Earth and the moon, where you're orbiting at the same speed as the moon does, so you go around once a month just as the moon goes around once a month. But it's a lot closer to the moon than it is to the Earth. So it's, from the moon's point of view, it's a fairly good transfer point. Well, and so what we need are some trade studies to evaluate which of those two orbits would be more advantageous in the long run. Which one would take the greatest advantage of lunar-sourced propellants? Which one would be wind up in the end, in the long run, with the lowest operating costs? Now, I didn't get very far much further in my formal diagrams, but my concept would be for the lunar propellants. First of all, you don't ever want to use lunar hydrogen. You want to, for propellant. You want to save that, because even if we find water deposits at the poles, lunar hydrogen will be a rare commodity, and you need to save that for life support and industrial activity at the surface of the moon. But it turns out with oxygen and aluminum, and possibly with magnesium in the mix, you can get a specific impulse which is plenty high enough for the velocity you need to lift off and land on the moon. And I envision that you would supply first lunar oxygen you'd start using it at the surface of the moon, refueling your lunar lander with lunar source propellants. Then, as you built up your transportation capability, you'd start supplying both of those things for the oxygen and aluminum to your lunar orbiting base, or your L1 base. And that way you could refuel your lunar lander at both ends, and you could perhaps start refueling your LEO to lunar vicinity vehicle. And then eventually, as you build up your transportation capability, you'd start supplying lunar oxygen to low Earth orbit. Because from an energy point of view, it's actually cheaper to get it from the moon's surface to LEO than from the Earth's surface to LEO. Even though it's closer in distance to the Earth's surface, it's less energy from the moon's surface.
So, people always talk about the space elevator from Earth, but it would be much more practical from the moon. Do you have any idea how tall it would have to be?
No, it would not be more practical from the moon because the moon doesn't rotate fast enough.
Oh,
Part of the way the space elevator works is use centrifugal force from a counterweight to hold the cable up. Well, the counterweight going around once every 24 hours gives you plenty of centrifugal force. Going around once every 28 days,
Not so much.
it's not going to. This might work on Ceres or Vesta, asteroids which have rotational periods of several hours. They're much less than 24 hours in both cases, and they're very low gravity objects. That might work there, but I don't think you
But
want.
then another way of keeping it aloft, I mean, and then have a funicular, use solar power, for example, and an ion engine to keep it aloft.
I don't want a system that requires active, that can't stay up passively. I don't want a system that, if your engine fails, you crash. Sorry. I just don't want to go there. In fact, I don't even like the idea of an space elevator from Earth's surface, for the reason that, okay, you cut the cable by some accident or some terrorist, and it starts falling back to Earth and starts wrapping around the Earth. And it's just like a giant meteor strike all along the whole Earth equator.
Yeah, actually, in the Mars trilogy by Robinson, someone on Mars, somebody cuts the cable.
Yeah,
falls to the
yeah,
surface.
that's why I'm leery of, and I have several other reasons, but I'm not trying to get an ultimate system that will work in the 24th century. I'm trying to get a century we can build now with technology we have now,
Yeah, so
and that will be sustainable. Now this will give us a point where we can get us a bridgehead so we can live long enough to develop the
so what
better
about
systems.
like a rail gun or something from the moon?
That's useful for freight, but the G's, a reasonable size railgun to get people off, it's going to have to be many, many, many kilometers long. And so I'm thinking, we know how to build rockets, and it's not the rockets. The expense of rocketry right now is not the propellant. Well, the highest cost for things like the space shuttle are the people in the system. The army, the standing army of people that has to be there whether you're flying or not. And so one thing you must do in the next generation of spacecraft, whether it's this or whether it's a modified Orion or whether it's something else, is to make it operationally much less complex so that standing army of people can be reduced significantly. If you really want your costs down, got to face up to what your cost, where the costs are, and right now they're the people. Propellant, especially if you're mining the moon for the propellant's going to be cheap, relatively speaking, relative to other things. So that's the basic architecture I have in mind. You have propellant depots near the moon and near the Earth. You divide up your transportation system so that you have each segment only does one job. You only go Earth surface to LEO and back. You only go from Earth orbit to the moon or lunar or near lunar orbit and back, and you go from the lunar orbit or L1 to the lunar surface and back, and each transportation segment only does that job. One advantage to going back to Earth orbit from the moon is if you're going to, it's much easier to build your heat shield if you're going to come back by aerobraking, or you take much less propellant if you're going to come back propulsively than it is to try to land on Earth's surface. So your heat shield design and thermal requirements and mass requirements become much less all of a sudden. And that lowers the weight of your system, especially the parasitic weight, you know, that doesn't do anything. It's not propulsion, it's not engines, it's not, it reduces that considerably. So if there are other comments that people have, other questions, or maybe people have other ideas that I haven't thought of.
Well, you know, there's something I think we need to talk about, and it's a concept that I'm sure several people, I know you know it backwards and forwards, I'm very familiar with it. I'm not sure if everyone online understands this concept as well as we do, and it's delta V. And I don't think you can intelligently discuss this kind of a system without at least having some grasp of that concept. So I'd like to just take a minute or so to explain it. When you travel around in space, you do it by changing your velocity. You change your speed. For example, if you're in a nice circular orbit in low Earth orbit, and you want to go up to an orbit that touches the moon, you speed up. And what that does is that changes your orbit from a circular orbit to an elliptical orbit. And when you get way out by the moon, you'll actually slow down. You'll be going slower than you were in low Earth orbit. And when you come back down to the low Earth orbit, which you will do every orbit, you'll go up and down every orbit. When you come back down to your low Earth orbit and just touch low Earth orbit, you'll be going much faster than you were when you were circular at low Earth orbit. And the distance, the amount that you can raise that orbit is determined by how much you change your speed. So that's the concept of delta velocity. And when you go to design one of these systems, what it's capable of doing and where it's capable of going is determined by how much delta V it can generate. And that's a very crucial concept to, you know, discussing which option you're going to go with.
And
so can you orbit both the Earth and the Moon? So that your orbit is actually around the Earth
you can,
and then around the Moon, like a rubber band.
You can
Yes,
do it. You
sure
can
can.
do it once. You can do what's called a figure eight sort of free return, which they did on the early Apollo missions. However, that you can't sustain that orbit without some propulsive capability over the long term. It does it once it comes back to Earth, and then unless you do something else, it will not return to the moon. But first of all, the moon's moved in that interval.
See, that's the key thing. You know, you hear about slingshot maneuvers with the planetary probes, and what that does is it uses the gravity of another object to change the orbit. And whenever you have an orbit that goes up to where the moon is, and the moon's not there, and comes back down to the Earth, you can stay in that orbit indefinitely, as long as you never get close to the moon. But when the moon orbits around and comes close to you whenever you're near the tip of your orbit, then the moon's gravity will slingshot you and change your orbit.
Right. In fact, I didn't get into this because it was only a peripheral related to the direct problem I was at, but you can use a slingshot orbit to your advantage later on. If you have one of these orbiting stations near the moon, either at L1 or in low lunar orbit, and you have propellant stored there for your spacecraft, you can use that when you want to go to Mars. You can use that by slinging yourself past the Earth to gain velocity, and then slinging out to an orbit that transfers you to Mars. And it turns out you only have to make a much smaller burn here than you would have if you had launch directly from low Earth orbit.
Right.
So you can and build your Mars vehicle or transport it to the lunar vicinity, and then when you come back from Mars, you use the same technique in reverse. You slingshot back past the Earth, slow down, so you don't have to use the entire delta V that would let you enter Earth's atmosphere. You just slow down enough to sling you back to the lunar base, and then you can use that same Mars ship for repeat trips. Again, using lunar oxygen plus whatever propellant you're using for fuel supplied from Earth. The oxygen is the greater part of the mass of your propulsion system for most propellant systems, certainly if you're using oxygen and hydrogen.
Now, I suppose another concept we ought to introduce when we're talking about delta V and how much it takes to go from here to there. And I believe Heinlein used this. I know lots of science fiction writers have. And that is, if you're in low Earth orbit, you're halfway to anywhere.
In terms of energy, that's right. In terms of, if all you want to do is escape the Earth, and then you don't care if you get anywhere after that.
Right.
He was almost right. Turns out that the kinetic energy of a circular orbit is exactly 1/2 of the velocity is the square root of 2 times. But the kinetic energy, because energy goes as v squared, of the escape orbit, or the parabolic orbit, from that same distance from the Earth, is exactly twice the orbital kinetic energy. So to a first approximation, he was right. But if you just get up to escape velocity, you'll sort of hang around in orbit in the solar system near the Earth. You need a little bit of extra oomph if you want to go to Mars, or if you want to go to Venus, or one of the other planets, or one of the asteroids in the solar system. You need a little extra push besides that just bare escape velocity.
Now, another little quirk of this thing, there's a lot of them. If you just start on the Earth's surface and go directly to the moon, like Orion or Constellation, whatever you want to call it, that's less delta V than if you go first to low Earth orbit and then go from low Earth orbit to the moon.
No, it doesn't matter whether you go directly from Earth's surface to the moon's vicinity, or you pause in low Earth orbit and go to the moon's vicinity. The energy is, the delta V is the same, pretty much. There may be some minor differences due to orbital tweaking, but basically once you're in low Earth orbit, you have already paid that cost. And so you only need the additional delta V between orbital velocity and going to the moon is almost the same as escape velocity. You don't need quite as much as escape velocity, but for rough approximations, saying escape velocity will do.
So your shuttle system essentially is perpetually fueled on this delta V.
Basically, this thing would stop in low Earth orbit, refuel. It doesn't have an infinite supply of fuel, but it does. What it does do is not have the heat shield required to break. The idea of Constellation was return to Earth's surface any time from any place on the moon. Well, this would require breaking that up a little bit into steps, so you wouldn't quite be able to fit that requirement. I'm aiming at a little bit longer term system where the moon, you're going to have enough capacity to take care of your emergencies on the moon where you are. Yes, you will sometimes require rescue to Earth or rescue from Earth. But you're going to have build in a lot more medical capability, emergency repair capability, and so forth at your lunar surface base.
It strikes me that what you were talking about fundamentally reducing kind of the manpower and active resources supplied, but it would seem to me, and please forgive me for kind of posing this question to you, it would seem to me by creating this infrastructure and 3 different delivery systems, so to speak, you would actually kind of compound the manpower, or at least the maintenance and.
Well, it would no, the manpower for the Earth to LEO system could be reduced. This would only make sense to construct this kind of three-step transportation system with the stations which would probably have to have people on them,
Right.
and with a ship that would have to have a crew on it. Although you could change crews at either, but that would only make sense if you really have enough traffic, sustained traffic, to justify it, and that gets back into sustainability.
I think another...
That basically, if you're really going to have human settlement, where you're going to have not only if you're going to have people staying for long periods on the moon, but you're going to have considerable amount of shipping to and from. And from includes the propellant that's coming back to low Earth orbit to help power the system. It only makes sense if you really intend to go for...
So we're talking a poker hand that's all in, right?
No, you design the system from the get-go with this in mind. You don't build up the capability all at one time. You'd start with probably your Earth to orbit system. Basically, that will make an efficient transportation system no matter what you're planning to do beyond Earth orbit. Then you get a propellant depot going in low Earth orbit, which is initially supplied from the Earth's surface. That means that your launch vehicles from Earth don't have to have all the propellant to get where they're going. They just have enough propellant to get to the fuel station, and then they can refuel to go wherever else they're going. So your vehicles can be designed smaller because they don't have to have such big tanks. Because they don't have to have the whole tankage to go from Earth's surface to orbit.
Somebody does to get the fuel up there.
Yeah, but you can get the fuel up there as part of one of the jobs of this less expensive Earth surface to LEO system will be to, so not the only job, but one of the jobs will be to provide propellant to your orbital propellant depot.
One way I would answer that question is, let's say I want to go from here, here in Houston, to visit the Eiffel Tower.
Yeah.
Now, one way I could do it is to build a flying car or an amphibious car and drive it to Galveston, drive it off the pier, sail it all the way to France, and then drive it from the coast to the Eiffel Tower. But that would be extremely inefficient because it's very difficult to make a car that would do all those things.
Yeah, it turns out that people have built amphibious cars, and it turns out they're neither very good as a car nor very good as a boat.
Right.
They will work as either, but they don't work terribly well.
So that would be one thing I could do, or I could drive my car down to Galveston, get on a boat, sail over there, then take a taxi to the Eiffel Tower. And it turns out that's really, even though it's a more complex system, in the long run, that's easier and simpler and cheaper to do than to build a car that will do all those things. And I think that's why this is a viable approach to this problem, is because the job of getting from the Earth's surface into Earth's orbit is very different from the job of getting from space in the vicinity of the Earth to space in the vicinity of the moon. And that's even different from going from space in the vicinity of the moon to landing on the moon and getting off the moon again.
Mm-hmm. Yeah. They are different transportation jobs, and different vehicles are better at doing different parts of that job.
We have an online question. It says sustainability is tied to profitability. And so what I guess fundamentally what the individual wants to know is, using the infrastructure that you have, do you see it not only self-sustaining, but taking it the next step?
It would probably help you become profitable because it would be economical to try certain things. One of the things I like, besides sending propellant back to Earth orbit for more space probes, not just probes to the moon, but anybody who wants to buy propellant, is I'm very fond of Dave Criswell's concept for putting lots and lots of solar cells in certain places on the surface of the moon, and then using that to collect solar power, using microwaves to beam that solar power back to Earth-orbiting satellites, and from those satellites down to the Earth's surface. It's somewhat similar to the solar power satellite, but you don't have to build the entire solar collector in space. You can use an object that's already in space, and they have concepts, which some testing has been done of, I understand, for converting lunar soil in place to amorphous solar cells. Now, amorphous solar cells are not as efficient as the more traditional crystalline cells, but they work. And since you've got a lot of lunar surface, if you're just converting local material, you just convert a bigger area.
Real estate is not a problem.
Real estate is not a problem on the moon right now.
Yeah, right now at least.
Yeah, that's a big key phrase.
You know, you mentioned profitability, and you know, if you're going to make a profit, two things are going to happen. You're going to have money coming in, and you're going to have money going out. Now, this transportation system really, it's similar to the question that was asked earlier about the helium-3. We don't know exactly what this system is going to do that's going to generate money. We've got lots of ideas. Anybody who's ever looked at going to the moon and doing so for a commercial reason has looked at this. But regardless of what your income is, even if you're just building a system to support an expenditure of, you know, a research station on the moon or a colony on the moon, and all it's doing is a sunk cost, still the key concept to either making a profit or maximizing your profit or minimizing your expense is going to be lowering the cost of this system, and that's life cycle cost. Cradle to grave, how much does it cost to build, how much does it cost to operate? And so all the discussion here has gone into our speculation, Larry's speculation, my speculation, of what we would do to build a system that would cost the least to get to from the Earth to the moon and back.
Yeah, well,
Especially the
the
lower
person
the
who builds
operating
the
cost.
system, how they're gonna make money
Right.
is from transportation.
Right.
They're gonna make money by transporting people back and forth to the moon, just like when they built the railroads. That was all private enterprise, built the railroads, they didn't give a crap what people were going to California for, they were just gonna bring them there.
Right.
You know,
I'm not sure that you followed through with your point, but I guess when you were talking about, what was it, Galveston to Paris, you were talking about low orbit transport. And if I'm
Well,
not mistaken, you're talking about
the
the
segment-
commercialization of low orbit transportation, correct?
Well, what I really meant, let me explain that analogy a little further. Consider the leg of getting from Houston to Galveston to be getting from the surface of the Earth to low Earth orbit. Consider the leg from Galveston to, oh, I don't know, La Harbor, to be the low Earth orbit to lunar orbit leg. And considering getting from the port through the city of Paris and, you know, to the city of Paris and to the Eiffel Tower, that's the leg that lands on the moon. And all I'm saying is those are three different jobs, and therefore it's justified to have three different kinds of vehicles, because in the long run, that's simpler, cheaper, and less difficult to do than to build one vehicle that did all those tasks.
Sure.
And I think that's the point I'm trying to get at. Whether we know what the profitability is going to be, we don't know really what the source of profit will be, if there's going to be a source of profit. But if you're going to have long-term human activity on the moon, what you'd like to do is have a transportation system that's as low cost to operate as you can manage, so that even if you don't have profits, you can afford to operate it.
Well, the
Yeah,
problem-
so actually the three sections might be three totally different companies.
They could be.
You know, one company that just moves from between Earth and Moon, but never lands on either end.
Absolutely. And there's even a railroad analogy to that, because railroads often had to cross bodies of water. And sometimes the railroad would operate a ferry service to get from one end of the lake or one end of the ocean to the other. And sometimes a second company would own that.
one of the liveliest debates I've seen today is over the debate that space exploration is not a virtue in itself anymore. And so the point that that I guess the individual online was speaking to in terms of profitability is that space exploration not being a virtue, you have to have the initial investment motivated by free market enterprise. So in talking about that low Earth orbit transportation, that as the first leg of this infrastructure you're talking about, it has to be profitable in order to build the rest of it. And I think that's what this gentleman, the point that this gentleman was trying to make.
Well,
So,
actually, that's what, for example, SpaceX is aiming at.
right. Yeah.
SpaceX is basically saying there is traffic going to low Earth orbit now. We can build a system we think will cost less to do that.
Gotcha.
And so we'll capture some part of that market. And in fact, SpaceX is aiming ultimately, as I understand it, to go to the fully reusable two-stage model. They have a two-stage vehicle, and they're ultimately, they haven't got there yet, but their aim is to be able to recover both stages and reuse. Again, Elon Musk in an interview says, we don't know yet whether that will prove to be the most economic thing to do, to recover the stages and reuse them, but we think it will, and we're going to try it out to discover whether it is.
I hate to break in, but I've just been informed by our host that we're going to be breaking for a wrap-up session to wrap up the afternoon sessions in a few minutes. So I guess we kind of need to cut this a little bit short.
Okay.
One thing I'd like to say before I turn it back over is I'm a big fan of using lunar materials, and when I looked at this years ago, there was just no way to make this remotely economical without using something like aluminum for fuel. Everyone has always assumed you would use lunar oxygen for the oxidizer, but at that time I found it was very much a novelty to consider the use of, say, for example, lunar aluminum for fuel, but it's very practical. It could be done.
As I say, the aluminum oxygen rocket has been tested, at least on a small scale. So we know it can work. And again, this is going to be much more sustainable, in my opinion, than the present, the original constellation architecture of the Ares 1 and Ares 5, and I don't think there was any chance of reusing very much of either of those vehicles.
Agreed. And wasn't that whole model built around roughly 4 or so sorties a year?
Yeah.
That's not a lot of fun.
It's sustainable. You not only need low cost, you need a high flight rate.
That's right.
And this would allow you, at least in principle, to achieve a higher flight rate.
Thanks a lot.
Yeah, thank you for that.
Where did he want us to go for the wrap-up session?
If you would, anyone who is interested in, please, once again, give name, credentials, and if you want contact, should any of our online viewers want to contact if they have any questions. If you're not obligated to give contact information, but please, once again, your name.
Well, yeah, I'm Jeff Larson, and I can be reached. My email is eljefe3126@netscape.net. And Larry's our host now.
I'm the guy who I came up with the idea, and Larry Friesen is Friesen, and I can be reached at LJFRIESEN@peoplepc.com.